Assalamualaikum and good day everyone. I am Madam Azlaini from College Matrikulasi Negeri Sembilan. This video is prepared to explain on chapter 1 of SK015 on matter. As an introduction to this topic, we start with a what is matter? So, matter is a name that scientists have given to everything that you can touch or see or you can feel or smell. Anything that has mass and occupies space is a matter. You yourself is a matter. Matter is made of tiny particles known as atoms. So, under this topic, we are going to learn into details on atoms and molecules, mole concept, and stoichiometry. However, this video will only cover on the first subtopic, which is atoms and molecules. We will start this subtopic with one simple question. The word atom is a Greek word which means something that cannot be split up. Why it cannot be split up? Yes, due to its very small size and very tiny. And this small thing composed of smaller parts of what we call proton, electron, and neutron. What determines the mass of an atom? Yes, the mass of an atom is concentrated in a tiny fraction of the atom itself, of what we call a nucleus. According to New Zealand scientists and Danish physicists, nucleus consists of protons and neutrons while the electrons move around the nucleus of the atom. And next thing that you might wonder is what is the charge of a neutral atom? May it be a positively charged or negatively charged? Proton is positively charged particles, whereas electron is negative. An atom has a neutral charge because the number of protons and electrons are equal. So next, let's recall these few terms before we go into more details on atoms and molecules. We shall start with the first term, which is number of protons, or some books, it is known as proton number. Or you might be more familiar with atomic number. They are all the same. So, number of proton is a proton number or the atomic number in an atom of an element. If we refer to an isotopic notation of an atom, the proton is located at the bottom part of the elementary symbol on its left side. And you will also find another symbol on the upper part of the proton number. That is to represent the nucleon number or number of nucleon. So what is it called for the total number of proton and neutron in the nucleus of an atom? Yes, it is the nucleon number. To determine how many neutrons, you need to minus the proton number from the nucleon number. Nucleon number minus the proton number tells you the number of neutrons. Hopefully by now you have recalled the basic chemistry that you have learned during your secondary school. So let's take a look at this example, taking sodium as an example. Since you don't see any positive or negative sign next to the symbol of the element, meaning that it is a neutral atom. For a neutral atom, the number of protons is the same as the number of electrons. Therefore, for sodium, proton number is 11, the nucleon number is 23, the neutron is 23 minus 11, which is 12. Since this is a neutral atom, so the proton number will be the same as the number of electrons, which is 11. What happens when atom lose or gain electron? Yes, it becomes ion. Ion has two types, anion or cation. When atom is or are gained by an atom, an ion is formed. By gaining electron, there will be more electron than proton. Therefore, an ion is a negatively charged ion. While when electron is or are lost by an atom, a cation is formed. Losing electron results in fewer electrons than proton. Hence, cation is a positively charged ion. For better understanding, let's take a look at this example. What is it called for two or more atoms of the same element having the same number of protons but different number of neutrons? Yes, they are known as isotopes. What are the similarities of isotopes of the same element? They have the same number of protons, the same number of electrons, and they share the same chemical properties. Isotopes of the same element differ in terms of number of neutrons and their physical properties. These are some of the examples of. What is the atomic mass of an atom? Atomic mass of an atom is the mass of an individual atom in atomic mass unit. You need to be clear that 1 AMU is not equal to 1 gram. 1 AMU is equivalent to 1.661 times 10 to the power of minus 24 grams. And how about the relative atomic mass of an atom? Relative atomic mass of an atom is the mass of an individual atom of an element relative to the individual mass of one atom of carbon-12. Relative atomic mass is the average mass of one atom of an element recorded in AMU unit divided by 1 over 12 times the mass of one atom of carbon-12, which is recorded in AMU unit as well. Relative atomic mass has no unit. What is it formed when two or more atoms bonded together? They form a larger unit, which is known as molecule. And the mass of an individual molecule in atomic mass unit is the molecular mass of the molecule. These are some of the examples of the molecules: water, carbon dioxide, chlorine molecule, and hydrogen chloride. What is the relative molecular mass of a molecule? It is the mass of one molecule relative to the individual mass of one atom of carbon-12. It is given by the average mass of one molecule in AMU unit divided by 1 over 12 times the mass of one atom of carbon-12 in AMU unit. Same as relative atomic mass, relative molecular mass has no unit as well. Instead of determining the relative atomic mass and relative molecular mass by using the comparison method with the carbon-12 atom, technological development has introduced mass spectrometer to determine the relative atomic mass and relative molecular mass for a particular element or molecule in more accurate method. What is a mass spectrum? A mass spectrum is a result recorded by the mass spectrometer. Mass spectrum of an element tells the number of isotopes present in the element, the mass of each isotope of what we call isotopic mass, and it also tells the abundance of each isotope, which is known as isotopic abundance. How to interpret a mass spectrum? Let's take rubidium as an example. This is how a mass spectrum is interpreted. Okay. From the mass spectrum, it tells you that rubidium consists of two isotopes. Since the spectrum has two peaks, means two isotopes, rubidium-85 and rubidium-87. The height of each line is proportional to the abundance of each isotope. So in this example, rubidium-85 is more abundant than rubidium-87. To calculate the average atomic mass of rubidium from the mass spectrum given, we are going to use this formula. Summation of the isotopic masses of rubidium times the relative abundance divided by the summation of the relative abundance. This will tell you the average atomic mass of rubidium. Substituting the value into the formula will give you 85.56 AMU, which is representing the average atomic mass of rubidium. And how to calculate the relative atomic mass or relative molecular mass from a mass spectrum. Taking the mass spectrum of copper as an example. So to calculate the relative atomic mass of copper, what you need to do first and foremost is to get the average atomic mass of copper as what we did for rubidium just now. Substituting the value into the formula will give you the average atomic mass of copper. And to get the relative atomic mass of copper, it is given by the average atomic mass of copper divided by 1 over 12 times the mass of one atom of carbon-12, which is 12 AMU. You will get the same value, it's just that the relative atomic mass has no unit compared to the average of copper. Thank you for watching. Assalamualaikum.